Okay, so let's get started. So in the last class, I had done APGP primarily. So today I'm going to take up questions on APGP and other progressions. So let's start with this one. So 1 by 1 to the power 4 plus 1 by 2 to the power 4, etc. up to infinity is pi to the power 4 by 90. And the sum of the odd terms is alpha, sum of the even terms is beta. What is the ratio of alpha by beta? So this is an infinite series. Right? And it is neither an AP nor a GP. So if you look at the denominator, individual denominator terms are in AP 1, 2, 3, 4. Right? But it's not a AP series. Right? So how do we do this? So first we look at what is alpha, what is beta. So alpha is the sum of the odd terms and beta is the sum of the even terms. So I can write the even terms as 1 by 2 to the power 4 common into 1 by 1 to the power 4 plus 1 by 2 to the power 4 plus 1 by 3 to the power 4 up to infinity. Right? Now, this sequence is the same as this sequence. So this is pi to the power 4 by 90. So this is this becomes 1 by 16 into pi to the power 4 by 90. So this is the value of beta. Now let's look at alpha. So I have 1 to the power 4, 3 to the power 4, 5 to the power 4. What is missing is 2 to the power 4, 4 to the power 4, etc. So I take this 1 by 1 to the power 4 plus 1 by 2 to the power 4 plus 1 by 3 to the power 4 plus 1 by 4 to the power 4 plus 1 by 5 to the power 4, etc., which is my original sequence. From this, I subtract 1 by 2 to the power 4 plus 1 by 4 to the power 4 plus 1 by 6 to the power 4, etc. So this becomes the sum of the odd terms. So that means this is alpha. So the first series is pi to the power 4 by 90. The second series is nothing but beta. Right? So this is minus 1 by 16 pi to the power 4 by 90. So which is 1 minus 1 by 16 is 15 by 16 into pi to the power 4 by 90. So therefore alpha by beta is 15 by pi to the power 4 by 90 will cancel out. So this is 15 by 16 by 1 by 16, which is 15:1. Here. Understood, everyone?
Yes, sir.
Yes, sir.
Let's move to the next one. A, N, and be the nth term of a AP. Now, this is an AP question. If the sum of the n terms is 700, the sixth term is 6, sum of the first 7 terms is 7, what is the value of AN? So basically, they are asking for this term. So let's use these two. So AN is given by A1 plus N minus 1 into D. And Sn is given by N by 2 into twice A1 plus N minus 1 into D. So that means A6 will be A1 plus 5D and S7 will be 7 by 2 into 2A1 plus 60. So you can simplify this as 7 by 2 into 2 into A1 plus 3D. So 2 and 2 cancels. So S7 becomes 7A1 plus 21D. So it is given A6 is 7. So A1 plus 5D is 7 and S7 is 7. So 7A1 plus 21D is also 7. So it's very easy to calculate A1 and D from here. You can directly equate the two because the values are same. So A1 plus 5D is 7A1 plus 21D, which means uh, 5D minus 21D is minus 16D equals 6A1. So A1 is minus 8 by 3D. So now you put this in any one of the two. You can put it in the first one. So you get minus 8 by 3D plus 5D is 7. So you have minus 8 plus 15 is 7D by 3 is 7. So D is 3. So if D is 3, then A1 is minus 8 by 3 into 3, which is minus 8. So now you got A1 and B both. So now you put it in this Sn. So Sn will be given by n by 2 into 2A1 plus n minus 1 into D. This is given as 700. Put the values of A1 and D. A1 is minus 8, D is 3. So n by 2 into minus 16 plus uh, n minus 1 into 3 is 700. So n into 3n minus 16 minus 3 is minus 19 equals 1400. So 3n square minus 19n minus 1400 equals 0. So this is a quadratic in n. So you can use the quadratic formula. N would be 19 plus minus square root of 19 square, which is 361 plus 4 into 3, 12 into 1400. So 12 into 14 is 16800 by 6. So n equals 19 plus minus. So this is 16,800 and 361. Okay. 16,800 and 361 is 617,161. So you have to find the square root of that. So square root of 17,161. So you start with 1, 1, 1. Then you get 7, 1. So 2 and 23. So 3, 69, 261. So 23 plus 3, 26, 1. So 131. So 131 by 6. So 19 plus 131, which is 150 by 6, that's 25. N cannot be negative. So no need to take that negative value. So N is 25. So therefore, AN would be 825. Which is A1 plus 24D, which is minus 8 plus 24 into 2, which is 72 minus 8, 64. Clear? Everyone clear? Okay. We go to the next one. If the sum of the second, fourth, and sixth terms of a GP, now this one is a GP question, of positive terms is 21, and the sum of its 8, 10, and 12 terms is 15309, then the sum of the first 9 terms. So they are asking for S9. So we know that in a GP series, Sn is given by the first term into r to the power n minus 1 by r minus 1. So we have to find out A and R from the given conditions. So the second term, so An is given by A into r to the power n minus 1. So the second term, A2 plus A4 plus A6 will be AR plus AR cube plus AR to the power 5, and this is given as 21, and A8 plus A10 plus A12, which is AR to the power 7 plus AR to the power 9 plus AR to the power 11. This is given as 15309. So from the first equation, we can take AR out into 1 plus R square plus R4 is 21. From the second equation, we can take AR to the power 7 out into 1 plus R square plus R4 equals 15309. So you divide the second one by the first one. So 1 plus R square plus R4 cancels out, AA cancels out, R7 by R becomes R to the power 6 equals 15309 by 21. So you cancel with 3, 7, 3, 5, 1, 0, 3 is 7, 20, 63, 9. So R to the power 6 is 729, which is 3 to the power 6. So R equals 3. Once you get R, you can put R in the first equation to find A. So A into 3 into 1 plus 3 square plus 3 to the power 4 is 21. So therefore, A will be 21 by 84 plus 1, 85 plus 9, 94. No, sorry, 81 plus 9, 90 plus 1, 91. So 91 into 3. So this is 91 into 3. So that's your A. So now you need S9. So S9 would be A into R to the power 9 minus 1 by R minus 2, which is 21 by 91 into 3 into 3 to the power 9 minus 1 by 3 minus 1. So 3 to the power 9 means 729 into 3 to the power 6, 27. So 7 to 9, 27, 63, 6, 14 and 6, 20, 51, 18, 4 and 1, 5, 7, 14. So 3, 8, 6, 9, 1. 19683 minus 1 is 19683. 21. Okay, so you can cancel this with a 7, cancel this with 13. So this you can already simplify here. So 1 by 13 into 19682 by 2. So cancel this with 2, 9, 16, 8, 4, 1. And this goes with 13. 13, 7 is 91, 74, 13, 5 is 65, 91, 7. So S9 is 757. Straightforward GP question. Clear? Okay. Now we take a question which is a combination of AP and GP. So X1, X2, X3, X4 is a GP. If 2795 are subtracted from the 4 terms, then the resulting numbers are in AP. So what is the value of 1 by 24 of X1, X2, X3, X4? So since it is given to be a GP, so you can take X1 as A and X2 would be AR, X3 would be AR square, X4 would be AR cube. So these are in GP. Now if I subtract 2795, then I get A minus 2, AR minus 7, AR square minus 9, and AR cube minus 5. Now this would be in AP. So if this is in AP, then I have to find the value of A and R from here, right? So how do I find the value of A and R if this is in AP? So if this is in AP, then the difference between the terms will be same. All this difference will be the same. And that's what we have to use. So the first difference would be the second minus the first. So AR minus 7 minus a minus 2. This will be equal to the difference between third and second, ar square minus 9 minus ar minus 7. Right? So you simplify this, you get ar minus a minus 5 equals ar square minus ar minus 2. Right? So you can simplify this. You get ar square minus 2ar plus a plus 3 equal to 6. Right? So this is one equation. Right? Clear? Understood, everyone?
Yes, sir.
The second equation would be the difference of the first and the second will be equated to difference between the fourth and the third. So I have ar minus 7 minus a minus 2 equals ar cube minus 5 minus ar square minus 9. So again, ar minus a minus 5 equals ar cube minus ar square minus 5 plus 9 is plus 4. So I have ar cube minus ar square minus ar plus a plus 9 equal to 0. So this is my second equation. Right? So now I have to solve for a and r. How do I solve for a and r from here? How do I solve for a and r? Can I get a solution for a and r from here? What is the best way to solve for a and r from here? Anyone? Okay. From the second one, you can write ar square into r minus 1 minus a into r minus 1 plus 9 equal to 0. So r minus 1 into ar square minus a plus 9 equal to 0. So a into r square minus 1 will give you r plus 1 into r minus 1. So r plus 1 into r minus 1 square plus 9 equal to 0. Right? So this is from the second one. From the first one, what do I get? A into r square minus 2r plus 1. So that's r minus 1 square plus 3 equal to 0. Right? So that means now I can write a into r minus 1 square equals minus 3. And I substitute this in this one. So A into R minus 1 square, this can be substituted with minus 3. So minus 3 into R plus 1 plus 9 equal to 0. So R plus 1 is 9 by
R
3.
is 4.
R plus 1 would be 3, right? 9 by 3.
Right. R is 2 then.
R is 2. R is 2. Now you can find A. So A would be 2 minus 1 is 1. So A would be minus 3. Clear? So now we've got both. So I can find out x1, which would be A is minus 3 and this is 2. So this is minus 3. This would be minus 3 into 2 minus 6. This would be minus 3 into 4 minus 12. This would be minus 3 into 8 minus 24. So therefore, the product will be positive for negative numbers. So 1 by 24 into x1, x2, x3, x4 will give you 1 by 24 into 3 into 6 into 12 into 24. 24 cancels. So that's 18 into 12. So which is 260. Here. Now we go to a slightly different kind of question. Consider two sets A and B, each containing 3 numbers in AB. Let the sum and product of the elements of A be 36 and B. Sum is 36, product is B. This is for the first one. Sum and product of elements of B. Sum is 36, product is Q. Let small d and capital B be the common difference of APs in A and B respectively, such that D equal to D plus. So let's summarize this. So I have AB, where the common difference is small d and capital D, and the relationship is capital D is equal to D plus 3, and small d is greater than 0. This is what is given. Right. Now, sum of the first series is 36. Sum of the second series is also 36. Product of the first series is P. Product of the second series is P. So now, how would I take the two series so that I can calculate easily? How will I take the terms? Both series have 3 terms, which are in X. So how will I take the 3 terms of the series? I can take it as A1 plus D, A1 plus 2D. I can take it like that. But it is easier if I take the terms of the first one as A minus D, A and A plus D. Or let me take A1. Okay. So this is the first series. And the second series is A2 minus capital D, A2 and A2 plus capital D. Right? So then from the condition of the sum, it is very easy to calculate A1 and A2. So the sum of A would be A1 minus D plus A1 plus A1 plus D. D and D will cancel out, 3A1, and this is 36, which gives A1 as 12. Sum of the second series will be 3A2. This is also 36. So that means A2 is also 12. So now I've got A1, A2. Now I need to find D and capital D and small d. So the product of the first series is given as P. Product of the second series is given as Q. So the product of the first series would be A1 into A1 plus D into A1 minus D, which is A1 square minus D square. This is given as P. Product of the second series is A2 into A2 square minus capital D square, which is given as Q. Right? And P plus Q by P minus Q is given as 19 by 5. P plus Q by P minus Q is 19 by 5. So you can do componendo dividendo here. So you add P plus Q with P minus Q. That gives you 2P. And then you subtract P minus Q from P plus Q. That will give you 2Q. So 2P by 2Q, which means P by Q, will be 19 plus 5, 24 by 19 minus 5, 14, which is 12 by 7. So P by Q is 12 by 7, right? That means 7P equals 12Q. So this is your relationship between P and Q. So now here you already know A1, A2, both are same, 12 and 12. So you divide one by the other. So A1 by A2 will cancel out. So P by Q will be A1 square minus D square by A2 square minus capital D square. And this is 12 by 7. And you know the value of A1, A2, both are 12. So that means 144 minus D square by 144 minus, now capital D is D plus 3. So D plus 3 square is 12 by 7. So this will give you a quadratic in D, and you have to solve for that. So that means 7 into 144. The easier way of doing this. Okay, let's expand this. 144 minus D square by 144 minus D square minus 6D minus 9. This is 12 by 7. And I can again do componendo dividendo. So I add the 2 and subtract, or I can, okay, let's do it directly. So 7 into 144. 144 into 7 minus 7D square is 144 into 12 minus 12D square minus 72D minus 12 into 9, which is 108. So 12D square minus 7D square, that's 5D square plus 72D. And then you have 144 into 7 minus 12. So plus 144 into -5 plus 108 equal to 0. So 5t square plus 72t. This would be 144 into 5 to 22 to 720. So 720 negative plus 108. 720 minus 108. That's 612. So minus 612 equals 0. So E would be minus 72 plus minus into power of 72 square. (72 square) 75184 plus 20 into 612. 20 into 612. 12240 by 10. So plus 5184 square root of this 132. So minus 72 plus minus 132 by 10. So minus 72, 132 minus 72 is 60 by 10 is 6. And the other one is minus 204 by 10, which is minus 20.4. So it is given to the positive. So you discard the negative one. So this is your value of P. So now you need P minus Q. So your P is P is A1, which is 12 into 144 minus T square, which is 6 square minus 36, and Q is 12 into 144 minus, this would be 9, so 81. So therefore P minus Q will be 12 into 144 minus 36 is 12 into 108, and this is 12 into 63. So 12 into 108 minus 63, that's 45. So 12 5 66, 12 4 the 48, and 6 4 5 40. Here P minus. Yeah. Okay.
Wait, sir, could you go back to the
Yes.
final answer? Could you go to the right? We can't see that.
Okay. Done.
Why did we do 45?
So this is 12 into 108. This is 12 into 63. Subtract 108 minus 63 with 45.
Acha. Huh. Okay. Yeah.
Right? Next one. Let A be a series, AP series 1, 6, 11, 16. B another series 9, 16, 23, 30. The two APs consisting of the first 2025 terms. What is the number of terms of A union B? So n of A union B is n of A plus n of B minus n of A intersection B. Basic set theory. So this would be number of terms of A is 2025. Number of terms of B is 2025 minus n of A intersection B. So this is what we need to figure out. N of A intersection B. That means I have to figure out how many terms are common. So for that, let's look at the series of A. So for A, the first term is 1 and the common difference is 5. So that means the nth term will be given by 1 plus n minus 1 into 5, which is 5n minus 4. So this is for A. For B, the first term is 9 and the common difference is 7. So the mth term will be given by 9 plus m minus 1 into 7. So which is 7m plus 2. Right? So I have to check for which value of m and n will the terms be equal. Like from the terms given, you can see 16 is a common term. This is the first common term of the two series. Now 16 is the fourth term of the first series and it is the second term of the second series. So n would be 4, m would be 2 for the value for the term 16, right? Which is already there. So therefore, if Pn has to be equal to Pm, then 5n minus 4 has to be equal to 7m plus 2. That means 5n minus, or you can write 5m equal to 7m plus 6. So the first value of n is 4 and m is 2. Here? Okay. So you put m equal to 2 here. You get n equal to 4. Right? Now, in this kind of a case, right, n will follow an AP whose common difference would be the coefficient of m, which is 7. And m will follow an AP whose common difference will be the coefficient of n, which is 5. So that means the next value of n will be 4 plus 7. So n should be 11. And the next value of m should be 2 plus 5, which is 7. You can check it out. If you put n equal to 11, you get 77. N equal to 7 into 11. 77 plus 6, 83, 5, 5. N should follow further. N should 5.
Sir,
Sorry.
you're substituting M for 11, not
Oh,
N.
yeah. Sorry. So 7 into 7 is 49 plus 6, 55 by 5, 11. Yeah. So this goes in this. So this will be 5, this will be 7. So this goes on. So the next value will be 7 plus 5, 12. N will be 11 plus 7, 18. So this will go on. Right? Now, I need to know how many terms I will have. Right? So for that, it is given that both the series will have 2025 terms. Right? So that means for the first series, T2025 for the first series will be the first term, which is 1, or you can put n equal to 2025 here directly. So 2025 into 5 minus 4. And for the second series, that would be 7 into 2025 plus 2. So 2025 into 5 minus 4 is 10121. And this will be more than that. 2025 into 7 plus 2. 14177. So that means it has to be less than equal to this number, 10121. Right? Because after that, the first series will end. Correct? Clear? So that means this term has to be less than this value. So 5n minus 4 has to be less than equal to 10121. So 5n has to be less than equal to 10125. So that means n has to be less than equal to 2. No, sorry. 5n. Sorry. Yeah. N has to be less than equal to 2025. Right? Okay. N has to be less than equal to 2025. Now look at this series. So this series is starting with 4. So A is 4 and B is 7. So I have a AP series which has a first value of 4 and common difference of 7, and the nth term has to be less than 2025. So the nth term of this series will be 4 plus n minus 1 into 7, which is 7n plus minus 3. So 7n minus 3 has to be less than equal to 2025. So 7n has to be less than equal to 2028. So n has to be less than equal to 72, 62, 78, 56, 68, 79, 63, 57. So that means n has to be less than 289.7. So therefore, n should be equal to 289. So that means the 289th term of this series will be the last term of the series which would have common values. So which means that there will be
Sir,
289.
289 is the term, right? Not the is the value of the term, not the term itself.
It is the nth term. Tn is T289. Is not the value of the term. This is value of n and m, right? N is the suffix of the first series, m is the suffix of the second series. So there are 2025 terms in the first series. That means n value has to be less than 2025, right? And out of this series, which is a series whose nth term will be 7n minus 3. So this value has to be less than 2025. So therefore, n value has to be 289. So there would be 289 terms in this. So this value will be 289. So that means this will be 2025 plus 2025 minus 289, which is 4050 minus 289. Which is 3764. Okay, here. So what is important here to understand is that if I have two AP series, there are two important concepts here. If I have an AP series whose first term is A1, next term is A1 plus D1, A1 plus 2D1, and another series A2, A2 plus D2, A2 plus 2D2, etc. Then the common difference of the series of common terms, we find the common terms by doing this. Tn of A equals Tm of B. This will give you an equation of Na and Mb. So Tn of A would be A1 plus n minus 1 into B1 equals A2 plus n minus m minus 1 into D2. So from here, you have an equation between n and m, which is n d1 minus n d1 plus a1 minus d1 minus n d1 minus d1 equals m d2 plus a2 minus d2. So n d1 equals m d2 plus a2 minus a1 plus d1 minus d2. So this is a constant. This will be a constant. Now in this d1, sorry, n will follow an AP whose common difference will be d, and m will follow an AP whose common difference will be d1. And this will give you the terms which are common to both. So the common difference of the series containing the common terms will be LCM of B1 and like here, if you look at this one, you check for N4 of the first series and N11 of the first series, right? N4 and N11 of the first series. What is the common difference here? N4 of the first series will be 5N. This would be 5 into 4, 20 minus 4, which is 16. And N11 will be 5 into 11, 55 minus 4, 51. The common difference is 35, which is the LCM of the two series. Common difference of the two series, 5 and 7. So these are the two important concepts that you need to understand. Here, okay. Okay. Now let's look at this series. 1 plus 3 plus 5 square plus 7 plus 9 square up to 40 terms. So this can be written as 1 square plus 5 square plus 9 square, etc. So there will be 20 terms here, plus 3 plus 7 plus 11, and there will be 20 terms here. Right? Okay. Here. So how do I evaluate these two series? So if you look at this series, this is my first term, this is my second term, this is my third term. Now this is clearly an AP series, right? So the AP series has the first term as 3, common difference as 4, right? So that means the Tn term here will be given by 3 plus n minus 1 into 4, which is 4n minus 1, right? You put n equal to 1, you get 3, n equal to 2, you get 7, n equal to 3, you get 11. So this is the series 3, 7, 11, etc. 4n minus 1 series. If you look at the first series, the terms 1,
It's in
5,
GP.
9, it's not in GP. This is not GP. GP is the ratio of the terms should be constant. This is not GP. This is square of it. 1, 5, 9 are in AP. Okay. If you look at the series 1, 5, 9, this is in AP. Right? Where first term is 1. So here Tn would be 1 plus n minus 1 into 4, which is 4n minus 3. So that means this will be a series which will be of the form 4n minus 3 square. And you are taking the sum of this. This is the series here. And this series is the sum of this series. So this is sum of 4n minus 1. This is this series. Clear? So this is these are the two series. Now you break this out. You write this as sum of 16n square minus 24n plus 9, and this is sum of 4n minus 1. And both have 20 terms. So n would be 1 to 20. So this is 16 into sum of n square minus 24 into sum of n plus 9 into 20, because n goes from 1 to 20. Here also n goes from 1 to 20. So 9 into 20. And this would be 4 into sum of n minus 1 into 20. So this is 16 into sum of the square of the first n natural numbers is n into n plus 1 into 2n plus 1 by 6 minus 24. Sum of the first n natural numbers is n into n plus 1 by 2 plus 9 into 20. And this one would be 4 into n plus 1 by 2 minus 20. And after this, you put n equal to 20 in both cases. So you get this as 16 cancelled 8, 3. So n equal to 20 will give you 8 into 20 into 21 into 41 by 3 minus 12 into 20 into 21 plus 180, and this will give you 2 into 20 into 21 minus 20. So you add up this, and take the sum. That will be the required sum. Okay. Okay, so that's all for today. We'll take some more cases in the next class. Okay. Thank you. Bye.
Um,